Okay, so what are we looking for? We've got no sound. So what would we first look at? Well, it wouldn't be the preamplifier or power amplifier, I wouldn't think, because preamplifier and power amplifier are two separate entities and they share a common power supply. So I'm going to look first at the power supply problem, possibly a blown fuse. I don't know. It could be anything really. It could be a blown fuse, a blown track, something like that, an open circuit transistor, regulator, something like that. But let's whip the cover off, have a look inside and see if we can work out what's going wrong. Okay, inside looks pretty sort of normal really. The two fuses at the back certainly look intact. I haven't actually checked them out. Small smoothing capacitors here, or filter capacitors, whatever you want to call them. No obvious signs of burning inside. It all looks quite nice and clean, apart from a thick layer of dust, which you expect with any amplifier of this sort of age. So nothing at first, anything obvious. There is this regulator here. You see this TO220 device here. It's obviously some sort of regulator, probably for a preamplifier stage. So I'd be interested to see if that's got any problem with it. And that, straight away, that suggests to me there's something wrong with that, because that transistor's stone cold. That transistor I would expect to run fairly warm. Now some of these resistors here, this power resistor here, but a lot of these power resistors here are fusible. So if there's a fault, they'll blow open circuit, and it could be something as simple as one of those transistors has gone open circuit. There's another transistor there actually, and likewise that's stone cold as well. I'm just trying to work out where it gets its supply from for the front panel. You can see it's lit up. It's not particularly bright, but it's lit up. And from memory, that's the same as the other one. The other amplifier I've got, the LEDs aren't that bright. So, okay, the next thing to do is to get the manual out and start probing around for some voltages. Just done a few static resistance checks, and I'm a bit suspicious of this fusible resistor here. Looks like it's open. And there's another one by the bridge rectifier, and that's also open. We've got unregulated DC at the fuses, so the supply is okay, but it looks like it's downstream from the supply. It doesn't look like the power amplifier is getting any supply at all. Not sure what these series resistors do, so we need to have a look on the circuit and ascertain what they're feeding. It could be the preamplifier supply, it could be the biasing network for the amplifier. Okay, there's two resistors. These are 805 and 806. There's 806 there, and 805 is on the top. And they're out of the collector of the transistor. So that's a supply to that regulator, and that regulator is supplying down here. It looks like it's supplying the power amplifier. Or maybe, what's this here? It looks like it may be even just supplying the tone controls. So there's a chance that maybe something's gone on the tone amplifier. I'm not sure. Unfortunately, they're fusible resistors, so I'm a bit loath to put a 270 ohm normal resistor in there. But what I could do is leave it on the dim bulb and power it up and see if anything gets hot. But this is going to be basically like a crude 17 volt regulator here to plus or minus 17 volt regulator for the preamplifier. Can't see what else that supplies at the moment. Coming down here, oh, it does go up here as well. Let's have a look. Where does this go to? Up here, along this track along here. Okay, no, it's all preamplifier supplies and things like that. So there's a chance that one of the preamplifiers have blown up. So maybe I'll stick a resistor in. So tack across this resistor here, tack across this resistor here. After I've done a continuity just to make sure there's nothing obviously dead short circuit on the supply, and I'll try and power it up with the dim bulb, maybe with a lower wattage bulb, and just see what happens then. Right, for the minute I've just tacked a 270 ohm resistor across these two positions here. For the sake of checking to make sure there's not excessive current passing, I'm just going to put my fingers on these two resistors. Now these are at fairly low potential. Obviously you have to be very careful when you're doing things like this. You need to be sure that you know what you're doing. You need to know what your sort of threshold of having electric shock is. This is going to be about 20 or 30 volts, and I'm I'm not actually touching the conductor, I'm only touching the resistor. I just need to know that these resistors aren't going to get hot quickly and I'm not going to damage the amplifier. I'm also interested in how bright the dim bulb gets as well, because I'm obviously going to be putting a bit more extra load on it, and so we've got the dim bulb in the background. So I'm just going to briefly power it up initially. I'm looking for anything getting warm. Okay, there's no sign of anything getting warm. Still doesn't sound like we've got any audio. Okay, so we'll turn it off again, and now we need to check to see if our supplies are any good on the actual amplifier itself. Okay, here's the problem. If I turn the amplifier on now with the speakers connected, do you listen for this sound? Can you hear the hum? The meters showed a DC level straight away. That's because the ripple's breaking through on the amplifier. And more important thing than where the damage occurs is you look at the speaker cone. Watch the speaker cone when I turn the power on. Let me just get you to an angle where you can see best. See the speaker cone move out, showing this DC supply. So that's showing me that the positive side of the supply's transistor's got a short, or one of the drivers is turning the output stage on. So we're looking for the capacitor that supplies the positive line has gone, the transistor connected to that, or the driver connected to that, has got a short circuit on it. That's what's taken these resistors out, these protection resistors. So I need to find the shorted transistor. I don't think it's the output stage or the output transistors itself. I think it's one of the drivers, probably one of these, maybe one of these drivers down here, behind this capacitor here, and just here. Need to check all those. Quite a common fault with these amplifiers actually. I don't know how robust they are on their output stages, but I don't think, luckily I don't think it's the main output transistors, but of course it could be. We need to take the bottom off and have a look, see what's going on. Okay, let's run through these output transistors. It's strange actually, I've never noticed this before, but the output transistor is mounted right down here, and there's a blank space here. You can see this, maybe a bit further back could help. Okay, let's check the output transistors. We've got 4 transistors here. One of them's mounted right down the bottom here. It's probably out of view, but we're just looking for the diode junctions on the transistor itself. So 707 there, 730 there, and it's clear on collector emitter. Okay, 717, 734, clear on collector emitter. The other channel, 714, 720. And 725, clear on collector emitter. Okay, long way round. 713, 725, and a bit leaky on the. No, that's alright. Collector emitter's okay. So that's good because the output transistors are intact. So we're looking now for a shorted driver. Now, as I said before, it's going to work. What I tend to do with these amplifiers, I haven't got the circuit diagram with me, so I'm just going to work back. I'm going to check these transistors here that I pointed out earlier, work myself way back and see if I can find a collector emitter short. That's all I'm interested really at the moment, a collector emitter short. I'll look for that first, and then we'll if we can't find a collector emitter short, we'll do a proper junction test. Okay, injecting some signal straight into the power amplifier stage, and if I do that from my signal generator, you can hear that I've got undistorted sound, and that's the right hand channel there on this ribbon cable. And if I move over, you can see it seems to be working okay when I do that, but if I inject any signal post the amplifier, the tone controls, you get very distorted sound. Okay, actually it's very unusual. That's the first time I think I've ever come across an amplifier with a preamplifier fault. This is the connection that goes to the tone control and feeds to the power amplifier section of the amplifier. I've disconnected that, and I've noticed when I power it up now I don't get that large DC offset. I get the initial pulse on the dim bulb, and that's it. And now if I inject a signal into the power amplifier stage, which is, make sure I get the right place, because obviously some of this stuff's got DC on it. I don't want to feed DC back into my signal generator particularly. So I feed in, where are we? Here. Turn the speakers on so you can hear a little bit of gain. You should be able to hear that. Where are we again? No sounds. Was working just a minute ago. Bear with me a minute. I'm just checking I've got everything turned on. Okay. Hear that buzz, so there's no reason why that. Oh, turn the generator off, that'll do it. Okay, put a bit of attenuation on. That's one channel, nice and clean sound. The other channel, yeah. So power amplifier stage is in excellent condition, obviously working. So the problem is further back at the preamplifier, which is this board here, and that's basically on the back of the tone control. It's got 2 op amps. Now it could be a shorty capacitor, I suppose, but I'm going to look now at getting that board out and having a look in there and see what's going on. Okay, I've ascertained that it's more than likely the tone control circuit that's sitting down here on the left hand side of the amplifier, and probably an op amp's got a short on it. This is the feed to the tone control at this point here, but at the back of the balance control. That feeds to the tone control and comes back and then is fed into the power amplifier, which is the power amplifier input here. So what I'm doing is I'm jumping out the tone control altogether, and I'm feeding the audio straight from the preamplifier straight into the main amplifier. So in theory, if I connect that up and switch this on, should have audio. I gotta love one woman, and we have. Till I die. Now the sound's very thin, possibly because there's a matching problem. Probably because the amplifier's output impedance is sort of probably a few hundred kiloohms, and maybe the input source is the source from here is too high impedance to drive the amplifier properly, but clearly got audio. A little bit of Tom Lehrer, and no effect on tone controls. She's my girl, and I love her. So clearly the output stage is working fine. I've just got to get this tone control off here and investigate why both channels have failed. As I say, it could be a capacitor. I still think it's something common to both channels, but we need to investigate that. Now what I'm going to do is just verify on the scope so you can see with the difference, because it's sometimes not easy to hear on the amplifier what the problem is, especially when you're doing it through a recording, a video. So I'm going to feed in this is the input to the tone amplifier. You see, it's a bit noisy because it's got a lot of pickup and things, but see a pretty good sinusoidal waveform on the scope. You can see that. Now look at the output of this amplifier. Now this is the right hand channel. You see that? You see, and I try and get the drive out of it, all collapses. So there's something seriously wrong with one of those op amps. Now these are stereo op amps, so one chip will affect both channels. That's why I initially thought it was going to be a power supply problem, but of course we're running through op amps that are stereo op amps. If they're damaged, they won't work. This is the other channel, same thing, awful distortion, and I think we've got an offset on here as well. Yep, we've got quite a strong DC offset on here of minus 15 volts on the audio output. So that's the reason why the amplifier occasionally trips, or doesn't trip protection circuitry, but goes DC. So I would suggest that's probably the second op amp, but we need to actually buzz out the inputs and have a look on the on the actual amplifier itself. So let me just see if I can get you into frame here. It's a bit awkward to set the camera up and I'm trying to work on it at the same time. So this is the tone board down the bottom here. You see these are the two op amps. There's one here and the other one's right around the back. Now I'm going to try and get in there, and I need to get round the back of that op amp for one of the comparators, but let me just see if I can get to this one. I think this is the output. You'll have to bear with me, you can't see the scope at the same time. Okay, so we've got a signal there and it looks pretty clean. I'm going to go to the other op amp. Now these chips are around the other way, so I have to sort of work around which pin's which. I think that should be the output of the other one. Very little coming out of that, so that might be one of the inputs. Okay, so I think I'm going to have to do is get this board off the amplifier, remove the tone board, and get this so I can actually work on it a bit easier.